Let's answer part A. Here we determine the time when the ball reaches the maximum height, and we will also have to determine the maximum height. So here I have given the diagrammatic representation of this situation. That is, the ball travels according to the function given by the function h of t equals negative 16t square plus 24t plus 370. So basically this is a quadratic function. So therefore the path of the ball is described by this quadratic curve or the parabolic curve. So at this point, as indicated here, the ball reaches the maximum height. So when the ball reaches the maximum height, at this point, its velocity is going to be zero. So let's use this condition velocity equals zero to determine the corresponding time and also the maximum height. For that, let me consider the height function, which is given by h of t equals negative 16t squared plus 24t plus 370. So to find the velocity function, basically we have to find the derivative of this height function or the position function of the ball. So let's find the derivative of h of t, which is h prime of t. And this equals, we should find the derivative of each of the terms. So it is negative 16 times the derivative of t square is 2t plus 24 times of the derivative of t is 1, and then the derivative of 370 is a constant, so it is 0. So I just skipped it. So therefore this equals negative 32t plus 24 times 1 is 24. So basically this function h prime of t represents the velocity of the ball. So now we set this up equal to 0 and find the corresponding time. So I'm going to plug in h prime of t equals 0. So therefore this becomes 0 equals negative 32t plus 24. We now solve for t from this equation. I add 32t and this equals 24. So therefore t equals 24 divided by 32, and so this equals this is 8 times of 4, and this is this is 6 times of 4, or I write this 24 as 3 eighths, and this 32 is 4 eighths. So now we have this factor 8 in the numerator and denominator. They cancel out, giving us just 3 fourths. So therefore we see that at time t equals to 3/4 of a second, or approximately, in terms of decimal, this equals 0.75 seconds. So at t equals 3/4 seconds or 0.75 seconds, the ball reaches the maximum height. Now let's determine the maximum height. For that, we have to plug in the value of t equals 3/4 into the height function. So let's do that. We copy the height function, which is h of t equals negative 16t squared plus 24t plus 370. We plug in t equal to 3/4 into this function. So we get h of 3/4, and this equals negative 16 times of 3/4 square plus 24 times of 3/4 plus 370. And so this equals negative 16 times 3/4 square is 916, plus this I can cancel it 6 times. So 6 times 3 is 18 plus 317. Can cancel this negative 16 and positive 16, and this is negative of 9 plus 18 plus 370, and so this equals negative 9 plus 18 is positive 9, and 9 plus 370 is 379. So therefore this is the maximum height reached by the ball. Can put its unit. It is 379 feet. Now let's answer part B question. And here we have to determine the high time when the ball reaches the ground. That is, this is the point when the ball reaches the ground. So at this point, its height is going to be 0. That is, h of t equals 0. So using this condition, we can solve for t. So I write this h of t, and this is equals negative 16 t squared plus 24t plus 370. We need to set this up height equal to 0 and solve for t. So therefore we get 0 equals negative 16t squared plus 24t plus 317. I divide by 2 now. So I get 0 equals negative 8t squared plus 12t plus 370 divided by 8 is by 2 is 185. So we have to solve this quadratic equation. You can solve this using the quadratic formula. So therefore I write t equals negative b, which is negative 12, plus or minus under the root of b squared, which is 12 squared, minus 4 times of a, which is negative 8, times of c, which is 185, and this is divided by 2 times of a, which is 2 times of negative 8. Let's solve for t now. So therefore t equals negative 12 plus or minus 12 square is 144, minus this will be, we have a product of 2 minus, so it is going to be a positive quantity. And then when we plug this into the calculator, we get 5920. It is a product of 4, 8, and 185, and this is over negative 16. So after solving for t, after plugging this expression into the calculator, we get two values of t, which are 5.617. This is approximately 5.617, and we also get one negative value of t, which we ignored it. So we found that time equals 5.617. This is in seconds. So this is the time when the ball reaches the ground.